I hope that jacket rips.
All right. Maybe we're going to be okay now. Okay, so lesson 7.3, rational exponents. I got this thing so zoomed in. If I end up, if you can't see where I'm right or something, or I look away, make sure you let me know it's off the screen. So, rational exponents. We're going to start with this. 4 to the 1/2 power. That's what we mean by a rational exponent. A rational number is a number that looks like a ratio or a fraction, right? And so the first thing that we need to realize is that 4 to the 1/2 power is the same thing as the square root of 4. You guys are familiar with square roots, right? What does it mean to have a square root? Yeah, so we're looking for a number that when you take it times itself, you end up with 4, right? It's kind of like exponents in reverse. Because if you think of, what is the square root of 4? 2. It's 2, right? And so if I have 2, how would I make it 4 by using exponents? All right, so 4 equals 2 to the second. All right, so you see the relationship. When we square a number, it gets bigger. When we have a rational exponent, a fractional exponent, it gets smaller. It's like taking that, finding the base of that number, right? So as we move through these examples, write each expression in radical form or write each radical in exponential form. So if we have, this is a number that's in exponential form, and by the way, this word radical, a radical is this. This is a radical. Anytime you're have that square root symbol, or as we move on and we use different numbers instead of just a square root, those are called a radical. So as we write each expression in radical form, 25 to the 1/2 power would be what? It'd be the square root of 25. That's all it would be, right? Okay. And if we change this to an exponential form, 18 to the 1/2 power. Okay? Does that make sense? Now we have to be sure that we're treating these radical exponents properly. When we have 5x to the 1/2 right here, how would I write that in exponential or in radical form? Well, what number, what character or what value has the exponent? Just the x gets the exponent, right? And so the exponent as a 1/2 means that this x, we need to find the square root of that. But what about the 5? Are we doing anything to the 5? We're just multiplying the 5 times the square root of x. Okay? Does that make sense? Compare that to this next one down here, 5x to the 1/2, where 5 and x are inside the parentheses. So now we have the square root of 5 times x. See the difference between the two?
Yes.
Okay. So make sure that you're treating those exponents properly for the base that they belong with. All right, how about this? How would I rewrite this in exponential form? 8x has to be in the parentheses, and then it's the product of 8x to the 1/2 power. Okay? So details are very important in this lesson, but making sure that you apply the radical or the exponent to the proper terms or the parts of the term in the expression. Okay? So now we don't only do square roots, we can do cube roots. And if you think about it, if some number a, and you take it to the 3rd power, and that equals b, then you can turn that around and you can find the cube root of b to turn it back into a, right? So if we have 4 to the 3rd power, what is 4 to the 3rd power? 64. 4 times 4 is 16, and then 16 times 4 is 64. So that would be 64. So then I could write it like this, the cube root, and make sure that you put the number in the right place. You don't want to write it like this because this means 3 times the square root, right? Make sure that you get this 3 up above the little notch in the symbol. The cube root of 64 is 4. Okay? See how that works? All right. So we can draw a connection between what we were doing here with when we had, like back on this slide, 25 to the 1/2 power, and it was the square root of 25. You know, when we're using, there's always a base form of things in math where you don't have to use kind of all the notation, but it would be okay if we put a 2 right there because we're taking a square root, right? And if we put a 2 right there, it just means we're taking the square root. Just like when we have on this slide, we're taking the cube root, the 3rd root of 64. So if we have a number like 64 and we want to take the cube root of that, is there a way to write that in exponential form? How would you write that as an exponent? It would be 64 to the 1/3, okay? So if we have an exponent of 1/3, it ends up as a cube root, just like if we have an exponent of 1/2, it ends up as a square root. Does that make sense?
Yeah.
Okay, so here's where I asked you to get calculators a bit ago. Hopefully we'll be able to get this done. Some of these numbers will not be too bad. If I want to find a cube root of 27, how would I write that exponentially, first of all? 27 to the 1/3 power. And what is that? 3. Okay. 3 times 3 is 9, and then 9 times 3 is 27. So 3 is the cube root of 27. All right. How about the 5th root of 32? How would I write that exponentially? 32 to the 1/5. Oops, I don't know why I said 1/5 and wrote 1/3. 32 to the 1/5. And any thoughts on what that might be? That's where the calculators come in handy. Okay, I may have to zoom out here a little bit so you can see the calculator better. These calculators that we use have a square root button. So if you wanted to find, you know, the square root of 16, you can hit the square root button and it tells you 4, right? Okay, but it doesn't have a button. These calculators at least don't have a button that lets us find like the 5th root or the 4th root or something like that. So we need to be able to turn those things into the exponential form because we can use the exponential form on these calculators. And here's how it works. If I want to find the 5th root of 32, just put in 32, and then it's this button right here, the y to the x power. You can hit that, and now I want it to be, the next thing that you enter is going to be the power of the exponent. So I want it to be 1/5, so I do 1/5 and hit equals. And so 2 is the 5th root of 32. Does that make sense? Okay, so I'll go through it again. So the 5th root of 32 is 2. And all we're saying then is that 2 to the 5th power is the same thing as 32. That makes sense? So you do 2 times 2, that's 4. Times 2 is 8. Times 2 is times 2. So 5 factors of 2 is 32. All right, we'll do the same thing with this one. For the 4th root of 10,000 to the 1/4 power. And then on the calculator, zoom back out here, put in 10,000. And then the button you push is this y to the x right here. Okay, and then put in what? 1/4 equals 10. Okay?
How would you get on this one?
I don't think those calculators have the same button. So I've tried to figure it out this morning how to get it on these calculators. I can't do it. So 10. Okay. What? There are other questions? Tessa.
Okay, so put in 1,000. It says yx 1/4. And it keeps giving me 5.6.
Well, did you do 1,000 or 10,000? Make sure you got enough zeros. 10,000.
I put 4 in.
10,000.
Are you supposed to do 4 zeros?
4 zeros, yep.
Okay. I got 10.
Okay,
I swear to you.
yeah, I think you were not hitting enough zeros. All right. So moving on here, simplify these. If we write these in radical form, 125 to the 1/3 power, how would that look as a radical?
Square root of 125.
Not square root, the cube, we can call that one the cube root, and then after that you just gotta start saying the numbers, like the 4th root, the 5th root. So we can say the cube root of 125. Remember, your calculator doesn't like that, you can't do a cube root, at least on these calculators. So you would put 125 and then y to the x 1/3, and it's 5. So 5 is the cube root of 125. Okay? And then 1,296 to the 4th root, we would write that as a radical. That's the 4th root of 1,296. And if you put that into your calculator, it should come out to 6. Okay? You doing all right so far?
Yep.
All right. Now, we already know how to do this. 64 to the 1/3. If we wrote that as a radical, it looks like what?
Cube root of 64.
Cube root of 64. I want to ask you a question. Where did that 1 go?
It's there, it's just.
Where is it?
Underneath.
It's just 64. because-
64 to the 1st power, isn't it? But we don't have to write it as 64 to the 1st power because that's just standard form.
Yeah.
Okay? So then what about 8 to the 2/3 power?
You have to.
We should know where the 3 goes. Where's the 3 going to go?
We go to,
Because where did this 3 go? So it's going to be the cube root, because the 3 moves to the outside with the radical,
then 8.
and then 8 to the 2nd. Okay, so we want to find 8, or the cube root of 8 squared. Okay? So, find 8 squared, which is 64, and then find the cube root of 8 squared. So we would find the cube root of 64, which is 4. Okay, does that make sense? All right. So 64, notice that I use a lot of the same numbers over and over because they're easy with the squares and the exponents and stuff. 64 to the 2/3 power is the same thing as the cube root of 64 squared. Okay? Whoops. 64 times 64 is 4,096, and then the cube root 1/3, 16. Okay? I want you to notice something along the way too here, if you haven't already done it. What if we reverse the operations? What if I did the cube root first and then squared it? What's the cube root of 64? We've already done that one. Cube root of 64 is 4. And then what's 4 squared? 16. So it doesn't matter which order you do those two operations. It's kind of like, it's just multiplying basically is all it is. So you can do it in any order. So if it's easier to find the cube root first and then square it, do that. If it's easier to square it and then do the cube root, do that. It doesn't matter which order. So how about 36 to the 3/2 power? So how would I write that? 36 to the 3rd, good. The 3 is on top, so it follows the base. And we just need the square root, so I don't have to put a 2 there. So 36 cubed, 36 to the third power is 46,656.
Yep.
And then take the square root of that. So it's 216, right? Okay. All right. Now we're going to work the other direction. So rewrite each radical as an expression with an exponent. So the cube root of 125 squared. We know the base is going to be 125 to
Two
the
over 3. 2 over 3.
2 over 3. The 2 stays on top since it's with the base, and the 3 would be on bottom. 125 to the 2/3 power. Okay? And then you can enter that. What's handy about doing this, by the way, if you change it back to this form, now you can do this in one step. Because I can put it in the calculator 125 and then hit y to the x and then do 2/3. And I don't have to mess with that square root button or anything like that. Does that make sense?
I got there, so. Yeah, I got it.
You got what?
625.
You got 6 over 5?
625.
625? I don't know why. 125 squared. 125 times 125. And then equals, and then 1/3.
I put 2
I still got, oh. Well, you gotta put 2/3 in the right spot, but 125, y to the x, 2/3 is 25.
I got 6.
Well, you got the wrong answer. I don't know what to tell you.
I don't know how.
Well, try it again and hit the right buttons this time. All right, how would I rewrite this one in radical form? 343 to the 4/3 power. Okay,
Are you dividing?
we're going back to this one then. Hit the same buttons I hit, Kara.
Okay.
Okay, 125.
125.
Y to the x,
Y to the x.
2/3
Great.
equals
Equals
25.
It's probably divided by 2/3.
I don't know.
Or multiplied by 2/3.
Yeah.
25. I did that.
All right, so now we're back down to this one now. 343 to the 4/3. So 343. Whoops. 343. Y to the x.
I think I know.
4/3. 2,401. Okay.
This is the part that
All right. Now, here's where things get interesting once again for us. We're going to solve some exponential equations. And you need to think about this. If 5 to the x is the same thing as 5 to the 3rd,
X equals 3.
then doesn't it make sense that x has to equal 3?
Yes.
Because you couldn't have like x to the 9 or 5 to the 9th equal that 5 to the 3rd. That doesn't make sense. So this x has to be equal to that 3. Okay? And so we can use that information to our advantage if two bases, if two numbers have the same base and they're equal to each other and the exponents are different, then we can set those equal to one another. So since these have the same base, 3, we can just do this. 9 equals x plus 2. Does that make sense? Okay, subtract 2, 7 equals x. So 3 to the 9th is the same thing as 3 to the 7 plus 2. Does that make sense? All right, I keep asking that. I'm nervous that it won't make sense. All right. Now these two numbers don't have the same base, but I want to know what x equals. So I've got to make this have the same base as this.
5 and 7.
Okay, so 7 to the x equals 7 squared, right? Because 49 is 7 squared. So I can change one side so that it has a base that's the same as the other side, which means that x equals 2. That's all that means, okay? Alright, so let's look at a few more examples here. 3 to the 3x plus 1 power equals 81. So I want to find a base of 3, because 3 won't simplify, will it? I can't take 3 any lower as like an exponential number. So how would I figure out what power I need next to the 81? Well, it's pretty simple. 81,
1/3.
no, divided by 3.
Yeah.
That's 1 3.
27.
Divided by 3 again, that's 2 3s. Divided by 3 again, that's 3 3s, and then you've got the 4th 3, which is this one. So it's actually 3. Listen, 81 equals
3 to 4.
3 times 3, that's 9, times 3 again is 27, times 3 again is 81. So 81 equals 3 to the 4th. Does that make sense? Okay, so 3 to the 3x plus 1 equals what? 3 to the 4th. So now that I have the same bases, I can set the exponents equal to one another. 3x plus 1 equals 4. Subtract 1, 3x equals 3, divide by 3, so x is 1. Okay? You with me? All right. Now, 25 to the x minus 1 equals 5.
Okay, we'll get, work the other way.
So 25 is what?
5 squared.
25 is 5 squared, but I've already got an exponent. When you've got two exponents next to each other, what do you have to do to them?
Multiply.
You have to multiply them. So this is 5 squared to the x minus 1, so you've got to multiply these. We're going to have to distribute that too. And this equals 5 to the what? 5 to the 1, even though we don't see it there. So now we need to take this and distribute. So that would be 2x minus 2 equals 1. Okay, because I want to set the exponents equal to each other. Add 2. 2x equals 3.
And it's gonna equal 1/2.
X equals 1 and 1/2. Oops, I ran out of page, sorry.
Did you do it the opposite way?
Could I do what? I don't understand what you mean.
Like make 5 25 and have it be a half?
Should work. If you changed, if you went the other way, 5 is the same thing as 25 to the 1/2. So if you had 25 to the x minus 1 equals 25 to the 1/2.
Yeah.
So then you'd have x minus 1 equals 1/2, right?
Yeah.
Add 1, so x equals 1 and 1/2. Yep. Yeah, that works. I didn't think of it that way. Good job. All right. Okay, sometimes you're going to have to change both numbers so that you get the base that you want, because what I know about 4 and 32, you don't have a power of 4 that equals 32. 4 squared is 16, but 4 to the 3rd is 64, so it skips 32. That means I've got to find a common base for the two numbers. So, well,
Yeah.
no, 8 doesn't go into 32 an even number of times, or as a factor. 2 is the number we're looking for, because 4 is really 2 squared, right? 2 squared times x minus 3, and we did a while ago, if you look back, 32 is what power of 2? Not 4, 5th, it's the 5th power of 2. So 32 is 2 to the 5th. So I can take 2 times x minus 3, distribute that 2, so it's 2x minus 6 equals what?
2 to the 5th.
Not 2 to the 5th, we're just talking exponents, so it equals 5. Basically, we're ignoring the bases at this point. We don't care what the base is. All right, add 6 to x equals 11. Divide by 2. So x equals 5.5 or 5.5. I don't care how you write it. Okay? And last example here before you get to, I'm going to unleash you on your own. I looked at this a while ago as I was going through my notes and I thought, gee, where did he get a g? But no, it's a 9. 9 to the x plus 1 equals 729. Now, huh? 81. Well, then we need a common base. 81 is not a base of 9. 9 will not give us 729. 3 is what we want. 3 squared. Oops.
9 times 81 is.
Yeah, 81 has
9 times, yes, but that still doesn't give us a base that we can use for the exponents to solve what we want. So 3 squared times x plus 1. Now I got to figure out how many times 3 goes into 729. So listen, I know the base has to be 3, right? So do this. 3, there's 1 3 times 3, that's 2 3s. There's 3 3s, 4 3s, 5 3s, 6 3s. So 3 to the 6 equals 729. Does that make sense? At least a little bit to some of you. So now what do I do?
Do the exponent.
2x plus 2.
So distribute this, so it's 2x plus 2 equals 6. Oops, where did I get a 3 from?
You're solving for us.
2x equals 4,
Oh, yeah.
x equals 2. All right.
Is it working?
Yes, it's worksheet for today.
What?